Okay, so here we have the two kinds of motion we are going to study this year. The uniform motion and the uniformly accelerated motion. Okay, so in both cases, in the uniform motion and in the uniformly accelerated motion, we have the trajectory that is in a straight line. But what is the difference? The difference is that in the uniform motion, we have a constant speed. The speed is always the same, while in the uniformly accelerated motion, the speed is going to be changing, okay? So we have the mean speed, you know that is the distance traveled divided by the time. In the uniform motion, the mean speed is going to be the same than the instantaneous speed in every instant. During the whole movement, the speed is going to be the same. While in the uniformly accelerated motion, we are going to have a mean speed, okay? But this mean speed is going to be different to the instantaneous speed, because in every instant we are going to have a different speed. The speed is changing, okay? So if the speed doesn't change, we are not going to have acceleration, while if the speed changes, we are going to have an acceleration. The acceleration is not zero, okay? And what is that? Where is the acceleration? This is the acceleration. The acceleration is the change of speed with the time, okay? The acceleration is the final speed minus the initial speed divided by the time, okay? If the speed is changing, the final speed is going to be different to the initial speed. That is why here we have an acceleration, while here the final speed is going to be the same that the initial speed. So one number minus the same number, we are going to obtain zero, no acceleration at all. Okay, so here we have the two equations we are going to use in all the problem of motion. Okay, the mean speed, it can be used whether in the uniform motion and also in the uniformly accelerated motion, okay? And the acceleration is something we are only going to use in the case we have an uniformly accelerated motion, in the case the speed is changing, because in the uniform motion there is no acceleration, okay? Something very important always when you use these equations, the units, okay? That is always very important. Here you have the units in the International System of Units for each of the quantities that appear in this equation. For the position or the distance travel, we usually represent it with an S of space. We use the meters, okay, in the International System of Units. For the time, we use the seconds. For the speed, the meters per second. And for the acceleration, be careful with this, meters per square second. Okay, these are the units in the International System of Units. There is obviously other units for each of these quantities. For example, for the distance travel, you can use also kilometers, decimeters, whatever, or for the time, hours, seconds, minutes, okay? But when you use these units, you have to be very aware. You have to remember always that in an equation, you can only have one unit for each physical quantity. Only one unit for each physical quantity. And what this means. Imagine you want to use, for example, for the mean speed, kilometers per hour. Okay, you can do it. But if you use kilometers per hour, you need to use kilometer for the distance travel, and for the time, hours. Something you can never do is, for example, putting the unit for the speed, kilometers per hour, and then the unit for the distance travel, meter. Because you would have two different units for the same physical quantity. You would have two units for the distance, meter and kilometer. There is something you can never do, okay? Only one unit for each physical quantity. What else about these equations? Okay, for this first equation, you can be asked, for example, you can be given the distance travel and the time, and you can be asked about the mean speed. Okay, that is easy. You just put here the data for the distance travel and here the data for the time, and it's no problem. Okay, but you can also, for example, be given the mean speed and the time and be asked about the distance travel. That is very easy. You just need to take the time to the other side of the equation and you will obtain that the distance travel is the speed multiplied by the time. Okay? Another thing you can be asked is about the time. They give you a data for the mean distance, for the mean speed, and for the distance, and they ask you about the time. Very careful with this. I always tell you that when my unknown is in the denominator, you have to be very careful because the first thing you need to do is taking the time to the other side of the equation multiplying, and they taking the speed dividing. Okay, you would obtain this. The time is the distance traveled divided by the speed. Okay? Where else? The acceleration. Here you have the acceleration, remember, in meters per square second is the final speed minus the initial speed divided by the time. So if they give you the final speed, the initial speed, and the time, you can easily calculate the acceleration. Okay? Something that is important that you know is that if you are increasing the speed, so if the final speed is bigger than the initial speed, you will obtain a positive acceleration. But if you are decreasing the speed, if you are going slower and slower, if the final speed is lower than the initial speed, you will obtain a negative acceleration, okay? Okay, so calculating the acceleration is easy. But what about, for example, if they ask you the final speed and they give you the acceleration, the time, and the initial speed? So very easy, you just need to take the time to the other side, multiplying, and the initial speed, summing, okay, summing up. So you will obtain this final speed equals to initial speed plus acceleration multiplied by time, okay? So this is all you need to know to do any kind of the problems of motions we are going to do this year, okay?